Hello everyone, hope you all are fine. Today we will start our topic complex variables. Hope you all know what is a complex number and what is a complex variable. Suppose z is equals to x plus iy. All of you know the notation of a complex number. Here x plus iy, x is your real part and iy is your imaginary part. Iota, this I stands for iota. Suppose z is equals to x plus iy is a complex number. Then f of z, that is a functional value of the variable z, is equals to f of x plus iy. This is called a function of a complex variable because it is a function of not a real number. It's a complex number, x plus iy. Here x and y can take any real values, but togetherly it will form a complex number. So it is a function of complex variable. Okay, so f of z is equals to f of x plus iy, which can be written to another complex, written in the form of another complex number uxy plus iota vxy, where uxy is a function of u is a function of x and y, which is real part of f of z, and v of xy is another function of xy, which is the imaginary part of f of z. Suppose let us consider an example. Okay, f of z is equals to sine z, that is trigonometric function, sine function. So f of z is equals to sine z, all of you consider as x plus iy. So sine x plus iy, this is sine a plus b. So expand likewise, sine x cos iota y plus cos x sine iota y, which will form sine x. Cos iota y is your cos hyperbolic y, and sine iota y is your iota sine hyperbolic y. Just substitute their values and you will form in this way: sine x cos hyperbolic y plus iota cos x sine hyperbolic y. This part does not contain any iota, so it's the real part of the function f of z, whereas this part has an iota, so it is the imaginary part of the function f of z. When a complex variable function satisfies some special property, we have discussed that what is a complex variable function. Now let us consider when a complex variable function satisfies some special type of properties, then we say this function as an analytic function. It is a new term for all of you. What is analytic function? Okay, so the function f of z, जो फंक्शन हमने पहले डिफाइन किया है, वो फंक्शन दैट मस्ट बी सिंगल वैल्यूड. दैट मीन्स फॉर एनी z value, when you put the value of z is equals to suppose 2 plus 3i, suppose you are putting z is equals to 2 plus 3i, then f of z will must give you only one value, not more than one value. Okay, then we call this function as a single valued function. So function must be single valued. This is the first case. Second case is it possesses unique derivative at every point of the region R. That means it must have a unique derivative at any point. Always we check the analytic condition for a particular region R. Okay, so region R में जितने सारे points होंगे, हर एक point में इसकी derivative, suppose जैसे sin h, साइन जेड की डेरिवेटिव होती है कॉस जेड. तो ये ऑल ओवर वर्ल्ड आप कहीं पे कोई भी रीजन लो, एलिप्टिकल रीजन लो, सर्कुलर रीजन लो, स्फेरिकल रीजन हो, हर पॉइंट में इसका डेरिवेटिव हमेशा ही कॉस जेड होता है. ओके, तो ये कंडीशन सेटिस्फाई होना ज़रूरी है. इट पॉजेसेस यूनिक डेरिवेटिव एट एवरी पॉइंट ऑफ द रीजन आर. तो हम उस पॉइंट फंक्शन को एनालिटिक फंक्शन या तो रेगुलर फंक्शन बोल सकते हैं. ओके, नेक्स्ट पॉइंट इज योर अ पॉइंट इन ए रीजन आर, जिस पॉइंट में फंक्शन सपोज एक सर्कुलर रीजन आपने लिया है, एक फंक्शन को आप एक सर्कल के अंदर चेक कर रहे हो कि वो एनालिटिक है कि नहीं। तो आपने हर पॉइंट के लिए चेक किया एनालिटिक है एक्सेप्ट एट द सेंटर सपोज। तो सेंटर जो पॉइंट है उस पॉइंट को हम उस फंक्शन के लिए सिंगुलर पॉइंट बोलेंगे। जिसका मतलब है कि जिस पॉइंट में फंक्शन एनालिटिक नहीं होगा उस पॉइंट को हम सिंगुलर पॉइंट कहते हैं। ओके, बट आपको एनालिटिक चेक करना है तो प्रैक्टिकली तो ये पॉसिबल नहीं है कि आप जो रीजन गिवन हो उस रीजन के अंदर इनफाइनाइट नंबर ऑफ पॉइंट्स होंगे, आप हर एक पॉइंट के लिए चेक कर सको, ये प्रैक्टिकली तो पॉसिबल है नहीं। तो इसके लिए एक पर्टिकुलर मेथड है। किस मेथड से हम इसको चेक कर सकते हैं? बाय फाइंडिंग द कॉची रीमन इक्वेशन, बाय चेकिंग द कॉची रीमन इक्वेशन। Okay, so there is a necessary and sufficient condition for a function to be analytic. Suppose function is your f of z is equals to u of xy plus iota v of xy. It is said to be analytic in the region R. It is said to be analytic in the region R if certain conditions are satisfied. First conditions is that del u by del x, del v by del x, del u by del y and del v by del y all must be continuous. That is the first order partial derivative of the function u and v with respect to x and y are must be continuous. Okay, and the second condition is your del u by del x is must be equals to del v by del y and del u by del y is equals to minus of del v by del x. These two conditions combinedly called as Cauchy-Riemann equation. If these two criteria are satisfied, then we can say that the function f of z is equals to u of xy plus iota v of xy is an analytic function. So without checking the derivative at each point, just by checking these two criteria, we can say that the function is analytic or not in a particular region. Okay, but in some cases it is difficult to form a Cartesian form of the function f of z. In that case we will convert it to polar form. All of you know this, z is equals to x plus iota y. In place of x, if you put r cos theta, and in place of y, if you put r sin theta, then z will be r cos theta plus iota r sin theta, which will form r e to the power I theta. So we can convert any Cartesian form to polar form, and then applying this Cauchy-Riemann equation, that is del u by del theta is equals to minus r del b by del r and del b by del theta is equals to r del u by del r. By checking this two Cauchy-Riemann equation for polar coordinates, we can also check the analytic function for polar form. Now let us consider a very simple example just to prove that a function is analytic or not, and if it is analytic then to find its derivative. It's a very simple example. Prove that sine hyperbolic z is analytic. Prove that sine hyperbolic z is analytic and find its derivative. So it is given that the function f of z is equals to u plus iv, that is equals to sine hyperbolic z. It is given to you sine hyperbolic z is your always x plus iota y. So expand it, sine hyperbolic x cos y plus cos hyperbolic x sine y. Thus u is equals to your real part, that is your sin hx cos y. V is your imaginary part, that is cos hx sin y. Now take the derivative, del u by del x, always we denote it as u subscript x. that is your cos hx cos y. Similarly, find out del u by del y, that is your minus sin hx sin y. Then del v by del x is equals to sin hx sin y. Del v by del y is equals to cos hx cos y. So the Cauchy-Riemann equation is satisfied, that you all can see very well. And what the second condition that you have to check also, that the first order partial derivatives with respect to x and y for both u and v must exist, must continuous, that is ux, uy, vx and vy all must be continuous, because you all know that cos x, sin x, cos hyperbolic x, sin hyperbolic x, these are continuous graphs. That means they are always continuous. Thus, we can easily say that their products are also continuous. So, ux is continuous, uy is continuous, vx is continuous and vy is continuous. So, both the conditions are satisfied. Then we can easily say that the function f of z that is given to you, sin hz, is analytic, and its derivative will be d by dz of f of z, that is your cos hyperbolic z. Hope you all understand this example and this topic. If you have any doubt or any queries, you can ask me. Thank you. Have a great day.